We're in the motorcycle lab of Washtenaw Community College. Southeast Michigan is the engineering capital, if you will, in the United States for automotive development. And we are here based on the demand to provide the talent necessary for the product development and service of the new vehicles they're developing. This recent model year Polaris Slingshot was purchased by the college and then modified to really showcase the types of technologies that are being taught at this college and are required in the product development of new connected and autonomous vehicles. And we have a dedicated short-range communication network in this vehicle that communicates with the building and other infrastructure areas, as well as other vehicles. And it sends out messages so that the vehicle knows where other objects are located, and other vehicles or other objects know where this vehicle is located. Here at Washtenaw Community College, our manufacturing and motorcycle and automotive technologies are utilizing new components that have been made out of lightweight yet strong carbon fiber types of materials in the panels, in one of the wheels, in several of the areas around the front end of the vehicle and other places. These are lightweight yet strong carbon fiber material components. Right here we've shown that we have a support for this left front wheel. That was done in our welding lab using a plasma jet cutter. We also created this bridge across the back, which has a cutout of the name Washtenaw Community College that is backlit with LED lights. Many of the brackets holding the LiDAR. We have a 360-degree camera here that's looking at everything around the vehicle. Many of these components and brackets were all created here through 3D printing technologies. A new manufacturing, relatively new manufacturing technology that does not require tooling. The Advanced Transportation Center was created to have an integration of 3 pillar programs. One was advanced automotive technologies and motorcycle technologies like we're seeing in this vehicle. Advanced manufacturing technologies, like we're always also seeing with the creation of components in this vehicle. And the third pillar is IT, the information technology, which includes not only computer networking and programming, but also cybersecurity, which is a very high priority item that you don't want to stick on as a Band-Aid later. You want this built in and part of the design of the vehicle, componentry and networks. So we have an auto cybersecurity workbench in our computer science and IT department that is used literally to help demonstrate in a laboratory setting which components can be hacked and how they're hacked in terms of programming, and also how to prevent that. The idea is to stay 1 or 2 steps ahead of them to prevent anything that would give the owner or driver of a vehicle a cause for concern. Vehicles like this one or any of the other vehicles out here have a major network called the CANBus. This is where all of the electronics really come together in terms of a control system, if you will. And from there, components and all of the functional capabilities of the vehicle are really summarized in terms of electronics. And it's that CANBus system that has to be protected against hacking, especially in areas that now have electronic power steering. They have powertrain controls, throttle and other actuators. The transmission shift position is now part of an electronic control system, and on and on and on. Our students and instructors as well are cross-functional teaching, if you will, across these 3 areas. Many students have a chance to learn networking and communications as part of their automotive or motorcycle technology learning.